Abo. So where were we stopped at electron deficient covalent hydrides. We will continue with electron precise covalent hydride kak koi. Abo. Electron precise covalent hydride mane hoise where the electron count is exactly perfect. That means not more, not less. Exactly jiman khini lage himane. Ye carbon or atomic number kiman hoy? Carbon or atomic number is 6. Electronic configuration of our 2 4. So I draw again these valence shell electrons in the vicinity of the carbon atom. Hydrogen keta ase 4ta. So I place the 4 hydrogen atom at the 4 corners. Yes, hydrogen or electron keta denote korisu by dots. It forms a single covalent bonds. 4 single covalent bonds form koribo swa. First single covalent bond, second, third and fourth. Carbon initially had how many electrons on its own? 4. 4 electrons it has again derived from the 4 hydrogen atoms. So carbon or electron count is exactly the perfect 8. For each of the hydrogen atom the number of electrons is 2. So this type of covalent because single covalent bonds form hoise dekhisa hydride bili koisu because the compound formed has hydrogen. Yes, electron precise bili koisu precise because it has the exact number of electrons, not more, not less. Electron rich covalent hydride. Ammonia, water are examples. Nitrogen or atomic number kiman 7 hone nai. Electronic configuration hobo 2 5. Valence shell electrons hold 5. So yate 1 2 3 4 5. Pasta electron for nitrogen atom akisu dikhisu mane tinta hydrogen atom ase jihetu ke tinta hydrogen atom moi tinir phale likhisu swa and their electrons are represented by 3 dots. This time again it forms your 3 single covalent bonds. When it forms 3 single covalent bonds, nitrogen or nizor valence shell electrons asil 5ta. In addition to it, 3 electrons have been derived from the 3 hydrogen atoms. As a result, nitrogen has 8 electrons now. What's it? 1, 2, 3, 4, 5, 6, 7, 8. Nitrogen has its share of 8 electrons. For each of the hydrogen atom, they have 2 electrons each. But at the same time, yate eta lekhot lobologia kotha hoise etu jodi moi ete bhalke aku tomar ammonia shape to enokwa 3 single covalent bonds dekhisa aru eta electron pair dekhisa na etu je this electron pair it remains just to itself tar mane just to itself mane ei particular electron pair te kono dhoronar bond formation participate kora nai. যেহেতু এই ইলেকট্রন পেয়ারটোৱে কোনো বন্ড ফৰ্মেশ্যনত পাৰ্টিচিপেট কৰা নাই এই পাৰ্টিকুলাৰ ইলেকট্ৰন পেয়াৰটোক আমি কওঁ তোমাৰ লোন পেয়াৰ অফ ইলেকট্ৰনছ. দ্য ৱৰ্ড লোন কামছ ফ্ৰম দ্য ৱৰ্ড লোনলি. হ'ব তাৰমানে দেখিছা নহয় ইলেকট্ৰন পেয়াৰটো অকলে আছে. ইট ইজ নট কাম ইন ফৰ্মিং আ বন্ড হয়নে নাই. এইকেইটা হৈছে আমাৰ বন্ড পেয়াৰ অফ ইলেকট্ৰনছ. ৱাই বন্ড পেয়াৰ? বিকজ এটা ইলেকট্ৰন নাইট্ৰজেনে দিছে এটা ইলেকট্ৰন হাইড্ৰজেনে দিছে. আ বন্ড হেজ বিন ফৰ্মড. So a type of electrons which are involved in bond formation I may call bond pair of electrons. Those electrons which are not involved in bond formation, they are known as lone pair of electrons. That is why the word electron rich mane ki apart from forming bonds electron roi goise hone nai in abundance in excess of electrons. So I may call electron rich, okay, covalent because you have covalent bonds here, and hydride because the particular molecule or compound is formed by reaction with hydrogen as one of the element. Clear? So 8 tinita ami as discuss korilu molecular hydrides, right? Molecular hydrides bili koisu. Molecular hydrides are of 3 types: electron deficient, one where the number of electron count is less. Eta hoise electron precise where perfect required number of electrons is there. The third category is electron rich hydride where you have more than the required number of electrons. Okay, so ami jetia hydrides moi discuss koriso We have talked about your last class of ionic hydrides. Aji ami porilo covalent or molecular hydrides. Aru the last category of hydrides is your metallic hydride naituba interstitial hydride buli koy. Hobo metallic hydride by interstitial hydride no ki etia. First শব্দটো তোমাৰ হৈছে interstitial comes from the word interstices. Itu swa? The spelling is interstices. Interstices means your gaps. Hobone? This is what tumalporo ase. Nize swa bhalke. As you can see, these are my fingers. Hone nai? Ei anguli ketar mazot you have gaps. Hone nai? Is a gap to ase? Hone nai? A particular gaps to kami ko interstices bili. Okay? Clear? Interstitial hydrides, the word comes from your interstitial comes from the word your interstices. Interstices mane onno eku nohoy, it refers to gaps. Ji gap burde thake hetuke tumar interstices bili koy. Etia metallic hydride kenake form hoy? Suppose eta metal or amar crystal ase, moi ene aki dekhaisu. Suppose this particular metal is nickel metal. Hobo ei jete nickel metal ase, এই nickel metal তুমি দেখিছা এইবিলাক হৈছে atoms lying on the surface of the metal. We know that solids or ক্ষেত্ৰত তোমাৰ কি হয়, the atoms they remain tightly packed. হেখিনি তোমালোকে জানাই. Liquids or ক্ষেত্ৰত the atoms they remain in a slightly lesser or looser mode of attachment. Or gases or ক্ষেত্ৰত the atoms have large intermolecular spaces between them. হনে না হেতু জানা? Se moi ene randomly nickel metal or surface to akisu. Hobo eta bahut aru atoms thakibo dei, moi ene just aki dekhoisu. Etu amar nickel metal or surface. Ei nickel metal or surface or bhitorot dekhisa ebur sob nickel atoms hoy. They are just atoms, okay? Ei atom bilakor mazor ekhini je gap dekhisa, ebur gap dekhisa ne? These gaps can be occupied by hydrogen molecule, hydrogen gas. And the resulting substance that will be obtained is known as a metallic hydride or interstitial hydride. Interstitial bili kyo koisu? Because hydrogen has occupied these gaps in between the metal atoms. Okay? Metallic bili kyo koisu? Because the reaction is taking place between a metal and hydrogen. But these are non-stoichiometric compounds. Non-stoichiometric or stoichiometric mane ki? Jeneke sodium chloride ami jetia likhisu, magnesium chloride ami jetia likhisu, definite formula ase ei compounds eta. Tumi sodium chloride bisarilo monere NaCl3 likhibo nwara. Magnesium chloride or MgCl likhibo nwara. They have a definite formula, a definite stoichiometry. Mane ki the one atom of sodium and one atom of chlorine will only react. Hobo etuk ami stoichiometry kau. One atom of magnesium and two atoms of chlorine will only react to give the compound. So yate ki hoy metallic hydride or khetron a definite stoichiometry is not followed. As you can see, this Ti refers to the metal titanium. Hydrogen to thake in the ratio of 1.5 to 1.8. Tar mane at one point of time titanium hydride formula ami 1.6 enekeu likhibo paru. At one point of time titanium hydride ami 1.7 u likhibo paru. Kyo? This depends upon how much amount of hydrogen has been absorbed by the metal surface. Understood? So these particular formulas are non-stoichiometric. Mane nirdishto formula hiotor nai. Gom paisa ne? Metal surface of metals buror mazot jiman gap thakibo hydrogen at that particular reaction condition, temperature, pressure or absorb jiman kini hobo, that will result into the formula of the metallic hydride. Am I clear? Vanadium hydride ami jeneke pau. Vanadium hydride or khetrotu vanadium is the metal, hydrogen dekhisa 0.56. Tamane a particular concentration to ami hydrogen pau. Hobo? So ji kuno tumar metal surface or logot tumar hydrogen dite react kore, you get interstitial or metallic hydrides. Okay? So here we come to the end of the topic hydrides. In my next class, moi tumalok PDF format of the topic hydrides I'll give you all. Okay? Till then all of you stay safe and keep well. Okay? Till then it's a bye from me.